Okay, welcome back, Algebra 2 Trig. We are doing 1.4, graph of functions. Go ahead and write the essential question. I'm going to put up some notes you also have to copy down. Okay, so the first one, I need you to copy down, talks a lot about functions and domains and ranges. Okay, so go ahead and copy that down. And I'll zoom in. So go ahead and pause it and copy it down. Okay, the next thing I need you to copy is whether a graph is increasing, decreasing, or constant. Okay, pause it and copy that down. And here's a great visual. Okay, so if it's decreasing, it is going down from left to right. If it's constant, it'll go flat. And if it's increasing, it'll go up, going left to right. And the last thing I need you to copy down is a couple of just kind of parent graphs to give you an idea of what the graph is. So this is a absolute value graph. So if you look, if it has an absolute value sign, it will always look like a V. And here are the domains and ranges and the increasing and decreasing key features of the graph. Okay, I also have a radical x parent graph you need to look at. So here is radical x. So every time you see a radical x, and it's not third root, it's just the second root of x, it's going to look something like that. Here are the domains and ranges, and we'll talk a little bit more about that. Okay, so let's do an example. So the first example is, hold on while I zoom out, sorry. Okay, so the first example, and actually the only example, is I want to determine the key features of the function f of x equals the absolute value of 2x minus 3. Okay? All right, so for now, before we do anything special, for now we're just going to pretty much do an XY table. Okay? All right, and another way to write y is also f of x. You need to understand every time you see f of x, it's y. Okay, so I need to pick values of x. Well, I want to know where the bottom of my v is, if you just saw that graph before. So the way I look for where the bottom of the v is I'm going to set whatever is inside the absolute value equal to 0. So I'm going to set this equal to 0. So 2x minus 3 equals 0. I'm not going to go through solving it too much, but x is going to equal 1.5 or 1.5. So I know the bottom of my v is going to be 1.5. So I want to pick points on either side of it. Okay, so let's pick points. So less than 1.5, I'll probably pick 0, -1, and -2. And on the other side of it, I would probably pick, since this was 1.5 away, I'll probably be pretty symmetrical, so I'll probably pick 3 and probably 4. Okay? All right, so now I'm going to do is I'm going to take these values, plug it in here, and get my y values. So or f of x value. So if I plug in -2, I'll do the first one all the way through. So I'm going to plug in -2 for x. So 2 times -2 minus 3. And that's the absolute value. So I know 2 times -2 is -4. -4 minus 3 is -7. So I'm taking the absolute value of -7, which is +7. Okay? So if I plug in all the other values, I'm not going to spend too much time because I know you know how to plug in. -1 is 5, 0 is 3, 1.5 is 0, 3 is 3, and 4 is 5. Okay? So now I'm going to go ahead and graph. I'm going to draw an XY coordinate. And I'm literally going to graph these points. So again, this is where the bottom of the V is. Okay? And I know that because I solved it for 0. So the bottom of V is going to be at 1.5, comma 0. And then my other points are 0, 3, negative 1, 5, and negative 2, 7. Oops, I graphed the wrong point. Forget that point. Okay? On the other side, I have 3, 3. So 1, 2, 3. And I also have 4, 5. I just want to graph enough points so I can kind of tell what my graph looks like. So I know it looks like a V. So I'm going to draw my V right now. All right, so now, looking at this, I can begin to tell the key features of the graph. Okay, so you have formal definitions. Let me give you my definition. So the domain, range, you're going to tell me where it's increasing and where it's decreasing. Okay, so the domain, in my own words, is probably all the values of x the graph covers. So if I look at this, whenever there's an arrow, that means if I look at this arrow, it's going to go on and on forever. So it's going to go up and to the left forever, which means if it goes left forever here, and I know this point's right, it has an arrow, so if it goes right forever here, then my domain is going to cover literally all my x values. So if it covers all the x values, I'm going to say my domain is all real numbers. Okay, so the range is all the y values my graph covers. So if I look at all my y values, well, y values are my values that are on the y-axis going up and down. So if I look at my graph, it doesn't go below the x-axis, but it starts here and it goes up, and it will go up forever because of that arrow. So I know all my y values start at 0, and it'll cover everything above 0. So the way I'm going to write my range is y is greater than or equal to 0. Okay. Now I'm going to look at my graph, see if it's increasing. So increasing meant it was going up, going left to right. So if I go left to right, I know it increases from this point, and it'll keep increasing. So it is increasing from the x value, it's going to be 1.5, because here's 1.5, and from then on it increases. I'm not going to count 1.5, because at 1.5 it doesn't increase or decrease. Okay, for decreasing, going left to right, it goes down from here all the way down. So it's going to be decreasing where x is less than 1.5. Okay? And then I want to consider anything that's constant, but I don't see anything that's going, just has a flat line, so I know it's not constant. So that's it. Today all you're going to do is domain, range, increasing, decreasing. If you have any questions, write it down in the questions box, and we will answer it the next day.